All right, guys, we are ready for our very last lesson in Unit 1. I know you're surprised, but you made it through it. This is your last lesson in Unit 1. You finished a unit in pre-algebra. Good for you. So let's talk about this. This is talking about comparing real numbers. This entire unit has been talking about rational numbers and what a rational number is. Hopefully you remember that a rational number is any number that can be turned into a fraction. Likewise, if you're talking about decimals in rational numbers, a rational number has a certain or a definite end, or it repeats. If it falls under any other category, if it doesn't have a definite end or it doesn't repeat, then it is not a rational number. That's what we've been talking about this entire time. So let's look at some more questions based on that. This says, here's some questions on here. This is a model of a baseball field. And it says the distance from the pitching mound to home plate is 1.3 inches. And it says, is 1.3 a rational number? Well, based on what we know about rational numbers, is 1.3 rational? Hopefully the answer that you're saying to yourself is yes, it is a rational number, and it wants an explanation. Why is 1.3 a rational number? And the answer is because it has a definite end. Okay? Remember, any decimal that has a definite end or repeats is a rational number. Well, let's look at the second question. It's talking about this model again, the same model of the baseball diamond. It says, on the model, the distance from first to second base, so here's first base for those of you who don't know much about baseball, and that's okay. Here's first base, and here's second base, and it says that distance right there is 2 inches. Is 2 a rational number? Hopefully, again, in your mind, you're saying yes. And remember, a rational number can be written as a decimal or as a rational number can be written as a fraction, but as a decimal, it has a definite end or it repeats. So can 2 be written as a fraction? Yes. And it's rational because 2 can be written as the fraction . 2 over 1. Remember, any whole number I can turn into a fraction by putting it over 1. Now let's look at number 3. It says the distance from home plate, which is this one right here, to second base, which is all the way up here. So straight across from home plate, that distance is a radical 8, or the square root of 8. And it says using a calculator, find the square root of 8. So here's my calculator. That's the first part of the question. So we're going to do that part first. So hit your radical sign. 8 equals, and it gives me this decimal, so let's write that down first. The decimal is 2.828427125. And it says, does it appear to terminate or repeat? Well, I can tell you right now that it does not repeat. None of these numbers are the same or in a pattern across. So it does not repeat. And then it says, does it terminate? Well, if I look at my calculator screen, does it fill up the entire screen? The answer is no. It doesn't go all the way across to where it looks like it doesn't have an end. So this one appears to terminate at 5. That appears to be the end of this decimal. It does not repeat, but it appears to terminate at the 5. So number 4 says, to determine if the number terminates on your calculator, multiply your answer to radical 8 by itself. It says do not use the squared button. We do not want to use the squared button. So we're not just going to push this button. We're actually going to take this decimal times itself. So 2.828427125 times 2.8427. I think I missed my 4. Hold on. 8427125. So I put that decimal in there again. and hit equal, and it says, does the answer equal 8? Well, it appears to be at the first, but if I look at the very end of this decimal, I have a 0.1 in there. So does it equal 8 perfectly? The answer is no. Because of that, we now know that this have an end. It appears to go on forever. It is not something that terminates, and it does not repeat. So is it a rational number? The answer is no, it is not a rational number. And the reason is because the decimal does not repeat. And it does not terminate. So if it's not a rational number, well then what is it? Well, if we turn the page, we have a whole new group of numbers. We've talked about rational numbers. The rational numbers are everything in this big white square. We've talked about all of those. But there's a little blue square over here, and it's called irrational numbers. An irrational number is not a rational number, so it's anything that cannot be written as a fraction or in decimal form. It does not repeat, or it does not have an end. For instance, pi, the symbol pi, right now it's been calculated to about 5,000 digits. So far it has not repeated, and it has not found the end of it. So therefore pi is an irrational number. This is an irrational number because it does not repeat and it does not end. That's what these 3 dots on the end mean, that goes on forever. So now let's use this information. I want to classify which sets of numbers these belong to. Well, if I look at 0.2525, and these 3 dots means it goes on forever, so it'd be 0.252525252525 forever. Does that repeat? Yes, the 2 and the 5 repeat in that decimal. So I know that it's a rational number. Natural numbers are this very middle one. Natural numbers are anything other than 0. So it's the counting numbers. When I count, I don't start with 0. So natural numbers are like 1, 2, 3, 4, 5, and so on. They're all positive and they don't include 0. Integers is where the negatives are thrown in there. It's the negative numbers and the positive numbers. And then rational numbers includes decimals and fractions. So this is a rational, and it's also a real number because all numbers, rational or irrational, are real. Believe it or not, there are things called imaginary numbers, but we're not going to talk about those in pre-algebra. So now let's look at number 2. Number 2 says a radical 36. Well, the square root of 36 is 6. Hopefully you remember that because we're going to be having a quiz on that very soon. Actually, by the time you watch this, we will have had the quiz on that. Radical 6 is 6. And so what group does 6 fall into? Well, when I'm counting, I say 6, so it's a natural. And then since it starts at the very end, it also includes all of these on the outside. So it's rational, whole, integer, rational, and real. Okay? Go ahead and do A through C and see if you can figure those out on your own. Stop the video and figure those out. Now we're going to do some comparing. And we're going to compare 2 numbers. On this first one, we're going to compare a radical 11 to a 3 1/3. So let's take the radical of 11. Radical 11 is 3.316. We're going to stop there. So this is 3.31. And if I actually rounded that, it would be 3.317. Well, 3 1/3, hopefully you know that that's 3.333 and so on, which means it goes on forever. So which one's bigger, 317 or 333? Well, hopefully you know that the bigger one is 333. So that is how I would put my inequality sign. All right, guys, I think you have a pretty good idea of where to start and a good foundation to do your homework on. If you have any questions, please come back and ask us them tomorrow. Have a great night. Bye.